Start. Ready to go. Okay, guys. So this is our topology. We are going to see an access control list lab. Also, we'll talk about the concepts here. So you could able to see that this is our organization router, COP1. On the left side, we have our computers, LAN network. On the right side, I'm connected to an ISP router, Internet Service Provider router, and somewhere out we have a web server and we have our FTP servers. Okay, FTP server or HTTP server, what you can say. Yeah, we have on the right side. So first thing, what we are going to do, we are going to assign an IP address. This is clear. All right. So what we are going to do, we are going to assign an IP address, and then we will discuss about access control list. What is the use of it? Okay, and how we are going to implement the rules on the routers, right? We will go and do some objectives, and we are going to see some types of access control list as per our topology, right? So quickly go and give an IP address. We have a PC1 here. It got an IP of 11, and the gateway is going to be .1. So I'll go here, desktop 192.168.100.11, and the gateway is going to be 100.1. Done. PC2 is going to be 12.1. It's going to be 13. Oh, it is going to be 13. And then 1. This is going to be 14. One is the gateway, and this server is going to have an IP of 172.16.10.3. Desktop 172.16.10.3, 255.255.255.0. 172.16.10.1 is the gateway for this server. Okay, so this is done. Computer and server is done. So let's go to the router. Now this router has two interfaces. FS0/0 is going to get this IP 192.168.100.1. Serial 0/0/0 is going to get this IP 220.20.21 with a subnet mask of 252. So let's go to the router, CLI and config T. So we will say interface FS0/0. IP add is 192.168.100.1. 0. No shut, and then the other interface serial 0/0/0. IP add is 220.20.21. 255.255.255.252. No shut. I'm not going to add a clock rate because there is no clock sign in front of it, and it is not a DC interface. Okay. So let's go to the other router, ISP. I'm going to ISP and going to assign an IP address. So the serial interface got an IP address of, what is it? 220.20.22. The subnet mask is 252. And we have to assign a clock rate 64,000. I'm going to say no shut. I do have a fast Ethernet interface 0/0. IP add is going to be, what is it? 172.16.10.1. 255.255.255.0, and I'm going to say no shut. Okay, so if you look at this, we are good to go, and they are going to turn from red to green. Okay, so about this, here I'm going to enable telnet on this web server. I'm going to enable telnet, and I'm going to enable SSH. Okay, and you can see that this is a router. I'm going to configure this router to act as a PC. I'm going to configure this router to act as a PC, not router. Because by default, a router requires a route to communicate with other networks, right? I'm going to disable the routing part from this router. So this is going to act as a computer. Okay, so I'm going to disable routing on this router. So it is going to act as a computer. Got it? So I'll go and then I'll configure telnet and SSH both on this web server. All right, so I'll go to this web server. First of all, we are going to assign an IP. What is the IP? I can see the IP is 172.16.10.2 and it has a gateway of 10.1. So PC require IP, subnet mask and gateway, right? So that is what we are going to do. So first we are going to disable the routing part here. So he is going to act as a PC. So I'm going to say no IP routing. This command is going to disable routing on this. So now this router is no more router. It is going to act as a PC, as a normal PC. So what normal PC require? An IP. So first we are going to give an IP, which is 172.16.10.2, and I'm going to say no shut. Okay. And what else it requires? IP address, subnet mask, and the third thing, gateway. So I'm going to say IP default gateway, IP default gateway 172.16.10.1, which is my router gate. Got it? Try to shoot a ping. Do ping 172.16.10.1 and you must get a reply. Yeah, I got a reply. Did you see this? So I have sent 5 ICMP packets. Some of them got dropped due to ARP resolution or ARP resolution. But next time when I'm going to do a ping, I'm going to get 100% success. Got it? 5 out of 5. So 5 ICMP echoes and 5 ICMP replies, we got it. Okay, now the third thing we are going to do, we are going to enable SSH. The first thing I'm going to enable secret over here, which is going to be Cisco 456. All right. Then I'm going to say what host name is given, IP domain name, IP domain name. I can say corp.com, whatever, my company name. Okay. And then the third step is, what is the first step? Host name, which is already there. The second step is domain name. Third step is we are going to generate RSA key pairs. So for that, we are going to say crypto key generate RSA. I'm going to encrypt the key modulus with 1024 bits and we are get to go. So we are generate the key pairs. Step number 4 is we are going to create a username. So we are going to say username admin and we are going to say secret Cisco @123 and we are done. You can say SSH is enabled and we are going to apply the SSH on the VTY line. So line VTY 0 space 4 and I'm going to say transport input all. If I say all, so it is going to enable telnet as well as SSH both. If I say transport input SSH, so it is going to enable only SSH on the VTY line. So that's why I'm going to say all, so it will enable telnet and SSH both over there. And I'm going to say login by local user, which we have created here. Done. Done with it. Save the configuration. Got it, guys? Okay. So let us go over here, server. Okay, go to the IP configurations. We have already done with the IPs. Now to we want this computers over here to communicate with this web server and the FTP server. For that, I require routing to be done on the routers. So on the COP1 router, on both of them, I'm going to run RIP just for the connectivity. So let's go to COP1 router. How many connected networks I have? 100.0 and 220.0. So for that, I'm going to go over here, okay, to the corporate router, and I'm going to run a RIP there for connectivity. So router RIP version 2 as it support VLSM. So I have two connected networks. This is the one, and the other one is 220.20.20.0. And I can say no auto, so it will not summarize. So this is done on this. And now I'll go to the ISP. ISP, we got two connected networks, 220.0 and 172.16.10.0. So we are going to advertise it. Got it, guys? Okay, so I'm going to say router with version 2, network 220.20.20.0, network 172.16.10.0, and no order. All right, so this is done. So if you go and check the routing table, do show IP route, and you could able to see that it has learned route about 192.168.10.0. And also if you go down to the corporate one router and check the routing table, do show IP route. You just want to see the routing table, and you can see that 10.0 routing has been, the table has been recorded over here. Okay, so if I go down to the computers, and if I try to do a ping to the web server, let us try to do a ping to the web server. What is the IP of web server? 172.16.10.2. From PC1, I'm going to shoot a ping to check the connectivity, right? So ping 172.16.10.2, and I'm going to hit enter. Let us see whether we are getting the replies or not. Timeout, and we are getting the replies, right? Yeah, the first packet drops because of ARP resolution. Next time if you ping, you're going to get 100% success, right? Okay, also try to ping that other server which is having, what is the IP? 10.3, right? So we are going to go there and we are going to ping 10.3 and you are going to get the replies again. Okay, is it clear? See, I'm going to get the reply. Let us try doing telnet to the web server there. What was the IP of telnet? We have enabled telnet and SSH here, right? So let's check whether we could able to do telnet from PC1 to the web server or not. So I'm going to go to PC1, right? Okay, guys, is it visible? Yeah. So I'm going to go to the PC1 and I'm going to say telnet. And what is the IP there? 192.172.16.10.2. Username was admin and password was Cisco@123. And I'm successfully there through the telnet. Come out and let's try SSH. For SSH, I'm going to use the telnet SSH client. IP address of our web server, which is 10.2. Username is going to be the admin. We are going to connect. Password is Cisco@123. Enter, and we are there. So our telnet is operational. We could ping the router, we could ping the web server, and also our SSH is operational. Let us go to server and enable HTTP and FTP. And we are going to do HTTP and FTP from here. So I'll go to this server. Yeah. What was the IP of this server? It is 10.3, right? So we are going to go to the services on the top, right? And you could see HTTP is enabled, right? HTTPS is also enabled. If you go to FTP, FTP is also enabled. What is the username? Cisco. The username is Cisco, password is Cisco, and these are the files we can fetch, or we can, if we use the command, we can get the file or we can put the file there. Got it? So what we can do, for an instance, let's say we will fetch this file 2800, okay, 124.15 T1. This file we will fetch from FTP server. Okay, and first we'll try to check whether we could able to have an HTTP or HTTP connection from our computers or not. So this time PC1 is done. I'm going to go to PC2, right? First, I'm going to shoot a ping whether I could able to reach there or not. 172.16.10.3 is our FTP and HTTP server. Got it? What is this? This is going to be our FTP and HTTP server. So what I'm going to do, let us go. First, let me check whether I could able to communicate. Yes, I could able to communicate with here. Okay, then I'm go to PC2. See, I'm still on PC2. I'll go to the web browser where it is. Here we go. What is the IP of that HTTP server? It is 172.16.10.3. Just type down the IP. See, I could able to get the HTTP connection. All right. Is it clear? Again, I want to check the HTTPS connection. So I'm going to say HTTPS colon double slash 172.16.10.3. Hit enter. And HTTPS is also operational. Okay. Let us try doing FTP. So I'll go to the command prompt. Okay. And I will say FTP 172.16.10 dot what is it? 3. Enter. Username was Cisco, password was Cisco. Right? Correct? So we are logged in into the FTP server. Right? You see that? Guys, what was the username? If you go to the FTP, the username is Cisco, password is Cisco. And we have read, write all this permissions to us. And these are the files. These are the files. If you want to see it from PC2, you can also see it from PC2 by just giving the command dir. So these are the files which are there in the FTP server. So let's say we want to get this file. Which one? Which one? I was talking about 2800. This one. Okay. So what I will do, I will just copy this file, right? And I can say get, and I can paste that file. Hit enter. So it is going to take some time, but it is going to fetch that file from FTP server to the PC. Are you getting it? So our FTP is operational, our HTTP is operational, our HTTPS is operational, Telnet and SSH. All of them are operational from here. Okay. It is going to take time. So let it give it a time. Okay. And it is going to fetch it. Is it clear? Now let's go down to our concept. Okay. What is access control list and why we are going to use access control list? Basically, guys, access control list is nothing but a kind of software firewall feature of an operating system, Cisco operating system, which is iOS. We are going to use access control list for filtering traffic. Okay, the traffic which is going from our LAN to out, we have to filter those traffic. We have to restrict the people inside our company to some services and allow for some services. That is what we can do with by using access control list. So basically, we are going to use access control list for two purposes. One is to filter traffic, and second is to define traffic. For example, if you want to go to the grocery and you want to buy stuff for your households, so you create a list, right? Am I right? And you will go to the grocery and buy those stuff which is there inside the list. Okay, so we can define the traffic by using access control list. For example, I want to send some traffic through a VPN, so I will put that traffic, those network addresses in that list and apply that list on the interface to go through the VPN. Are you getting it? So the purpose of access control list, we have two purposes. One is to filter traffic and another is to define traffic. Guys, as a name, access control list, what do you think? Yeah, it is a list, right? And the list is going to have entries inside it. Like we set a to-do list, right? And we set it on the priority basis. The number one priority, I want, let's say I want to buy something important, so I will put down in a number one point. So this is how we sequence our access our list, right? Similarly, access control list also contains access control entries, which are nothing but permit or deny statements. What are those? Which are nothing but permit or deny statements which will be filtered in a sequence. Okay. So access control list is going to have access control entries. What it is going to have? ACEs, access control entries. Okay, access control entries are nothing but permit or deny statements. Okay, and those permit or deny statement is going to filtered in a sequence. So, like for example, I added one entry like deny this, deny 192, 168, 10.11. So this is going to get a sequence number of what? 10. Are you getting it? It always starts with 10 and increment by 10. So let's say I added one more entry. Deny 192, 168, 10.12. So what sequence number it is going to get? Not 11. It is going to get 20 because it is going to increment by 20. And also when it is going to filter, it is going to see the first statement and then the second statement. So it will go in a sequence one by one. Got it, guys? So every time I'm going to add any entry, it is going to increment by sequence number 10 all the every time that I'm going to add any entry. Got it? So I'm going to set some objectives here. Okay, look at this. I want to deny 192.168.10.11. Okay, so I don't have 10, 100.11, which is nothing but who is nothing but PC1. I want to deny PC1 to access everything. It should not access nothing. Okay, okay, he's not allowed even to send a ping packet. Okay, I want to deny him completely for all the services. Okay, and then I have to allow rest of the computers for all the services. This is one of first. This is my first objective. Number one, I have to deny how many computers you can see in our topology. Four computers. PC1 got an IP of what? Hello. PC1 got an IP of 100.11, right? PC2 got an IP of 100.12. It got an IP of 13, 14. So we have four computers, and my objective is to deny this guy to go anywhere. This guy is, like, is a pain. Whenever I give him access, he might make a mess. Okay, so I don't want this guy to permit to go to anybody else, right? Okay, I'm just given him some, local inventory and just work on locally on the PC. So I don't want this guy to go anywhere and should not access any services. Okay, and I want these people to access all the services. That is my objective. Now, guys, there are three types of access list we are going to see. There are many types of access list, but as the CCNA is concerned, we are going to see how many types? Three types of access list. How many types? Three types of access list. Guys, stay tuned. You know, show your interest. Do not keep your mind intact. Concentrate. Okay, okay. Don't miss out anything. Okay. So three types of access control list we are going to see. One is standard access list. What is standard ACL? The second one is extended ACL, and the third one is named ACL. Three access lists. How many access lists? Standard access list, extended access list, and named access list. Okay, let's talk about standard access list. How we can identify a standard access list? It is a numbered access list. It is a numbered access list. It is a numbered access list. That means you cannot give name to this access list. Okay, how you're going to identify that this is a standard or extended access list? If you see a number from 1 to 99, like access list 1, access list 10, access list 50, access list 90, these are standard access lists. Any number in a range of 1 to 99 indicates standard access list. Whereas extended access list is also a numbered access list. And how we are going to identify extended access list? Any number in a range of 100 to 199, it is going to be an extended access list. So can you tell me access list 150, which is it? Extended, right? Access list 50, standard. Access list 99, standard. Access list 160, 199. Got it, guys? Let's discuss the other difference. Standard access list. Let's discuss the other difference. Standard access list filters traffic based on source IP only. It is just gonna see the source IP. It is not gonna see where you want to go, destination IP. It is not gonna see what protocol is going to use for transport, TCP or UDP. It is not gonna see what services it is going for, whether it is going for Telnet or SSH. It is just going to see the source IP. If the source IP is denied, it is completely denied for all the services. If the source IP is permitted, it is completely permitted for all services. Completely deny or completely permit for all services. So for example, if I say deny 192.168.10.11, so it is going to completely deny for all services. Even you cannot able to do ping. You cannot able to do ping. Are you getting it? So when I say standard access list, it is not going to see anything. It will just check the source IP. It is just kind of a security guard who is going to stand in front of the interface. Are you listening to me? It is going to stand in the front of interface. If it will see only the source IP, okay, this is a source IP. Deny. You cannot go from the interface. The interface, you are not allowed to get forward the packets from the interface. Okay. So that is what standard access control list is. Okay. Whereas extended access control list is going to filter traffic based on, okay, is going to check the source IP. What is the source IP? It is going to check where you want to go, the destination IP as well. It is going to check what protocol you are going to use for transport. Okay, a transport protocol, like what protocol you are going to use. Either you are going to use TCP or you are going to use UDP or you are going to use IP. It is going to check. It is also going to see what source port you are going to take. Okay, it is also going to check what destination port you are going to take. Okay, and it is also capable to filter traffic based on TCP and UDP flags. TCP and UDP flags. Flags like what? Like SYN, okay, or like ACK, or like reset. These are the flags which we used for TCP and UDP connections. So extended access list is going to see all of this. Okay, and on the basis of this, it is going to deny or permit traffic. Okay, so we have to mention all of this when you are when you are putting an entry into the extended access list. But when it comes to standard access list, you are just going to put down a source IP address. That's it. Got it, guys? So let's go for our first objective. So can you tell me which access list we should use, standard or extended? We have to deny 192.168.100.11 to access everything. Okay, so we want to deny 100.11 for all services. For what? All services. So what we are going to use? Obviously, we are going to use a standard access list, right? And allow rest of the computer for all the services. So we are going to use a standard access list, which is in a range of 1 to 99. Remember one thing, you can only use one access list per interface. Remember, you can apply an access list per interface. So let's go to the configuration part and we will discuss the named access list later on. So step number one, you know, what is it? You have to create an access list. You have to create an access list. Step number two, apply an access list. Apply an access list on the appropriate interface for inbound packets or outbound packets. What do you mean by inbound and outbound packets? Now look at this. Yeah, I'll just discuss that in a moment. So let's go to our topology. Okay. Now see, these are the PCs which are going to access the web server and the FTP and HTTP server, Telnet and SSH server, FTP and HTTP server. So when this traffic will go from this router, yeah, this interface is facing towards this. The traffic is going to flow in this direction, right? Am I right? So for this particular packet, when it is going out, for this interface, this is going to be the inbound packet. Am I right? Packet coming inside the interface, inbound packets. Are you getting it? This is the door. This fast Ethernet 0 is the door. For this traffic, when it goes out, it is going to be inbound packet, right? Am I right? Okay. All right, guys. Now for this router, are you listening to me? Look at this. Now this interface, serial 0/0/0. For this, what this packet is going to be? For this packet is going to be outbound packet. And for this, what packet is going to be inbound packet? The one which is coming from outside, inbound. So this is going to be the inbound packets in direction, and this is going to be outbound for this serial interface. For this is going to be inbound. Am I right? And whatever goes out of this is going to be outbound packets. Got it? So this interface for this, it is going to be inbound, and anything comes out from this, it is going to be outbound. Look, similarly, this is facing towards this. So whatever goes in this direction, those are outbound, and whatever comes in this direction, those are inbound packets. So if you are filtering traffic for this PCs, you better apply on this interface FA0/0 for inbound direction. So the packets will be dropped here itself. Are you getting it? They will not go to the serial interface. Okay, so whenever you are applying an access control list for these people, you will apply it for inbound direction on this interface. Okay, so they will be dropped over here itself. Okay, so what is step number one? Create an access list. So we are going to go and create an access list, right? Enable config T, and you are going to say access list. Okay, I'm just going to use any number in a range of 1 to 199. So I'm going to use access list 50, which is going to be a standard access list, and I'm going to say deny host 192.168.100.11. Okay, okay, look, guys, listen to me. If I do it this way, just one statement in my access list, deny host 192.168.100.11. What about this one? Are they going to get permit or deny? If they are not in a traffic, they are going to get deny by default. So if you want them to go outside the router, you have to give an allow statement. If you did not give it, it is going to deny everybody. Are you getting it? If the entries are not in the list, they are denied by default. So if you want to allow them to go out of this interface, so we are going to say access list 50 permit any. So this is going to be the first statement. It is going to deny 11, and it is going to permit rest of them. This is what we are going to do with a standard access list. Got it, guys? This is our objective, right? Objective number one. Okay, so here we are going to go and we are going to create a first statement to deny 100.11 and the second statement to permit all. Guys, always remember, give deny statement first, permit statement second. Okay, always use deny statement in the beginning and permit statement in the last. Okay, guys. So what this command is going to do, it is going to deny this and it's going to permit everybody. So this is what step number one, right? Right, guys? So this is the step number one. Okay, what is step number two? Step number two is to what? Apply the access list. Yeah, apply an access list on the appropriate interface. So I have already told you that where we should apply it, right? It is better you apply it here itself on the fast Ethernet interface on this door. Okay, so it will be dropped here and for inbound direction. So what we are going to do, we are going to the corporate router and then we will say interface FA0/0 and to apply we are going to use IP access group command. IP access group. What is the name of the number of access list? 50. And for which direction? For inbound direction. So any packet which is coming inside fast Ethernet 0/0, this you have to go through this list. Any packet which is coming inbound fast Ethernet 0/0, you have to see the list. If your entry is there for deny, you are going to get deny. If your entry is there for permit, you are going to get permit. Okay, guys. So if you apply this access list on this interface, so any packet which is going to get inside this interface, inbound packets, are going to filtered through the access control list which we have applied. So we have said deny 11 and permit rest of them. So see, if you could able to see previously it was pinging to everything. Am I right? And also the telnet was successful. But this time if you try to ping, it is going to get denied. 10.2. So it is going to get denied. Destination host unreachable. In fact, he could not able to go to HTTP and FTP server as well. He could not able to do anything. Are you getting it? Telnet is also denied. Yeah, 192.172.16.10.2. It is denied. You got it? And if you go down to the corporate router, you will see these entries. How many packets has matched? You know. So what is the command? Show access list. So it will tell you that 20 matches are been done and we have denied 20 packets. Okay, from 11. Did you see this? And do you see what sequence number it got? The first statement 10 and the second statement 20. The second statement is permit any. So that means PC2. Are you listening to me? That means who? PC2, PC3, they could able to do it, right? So if I say quit here to come out of FTP, okay, and so if I am doing ping, I could able to do ping, right? So 172.16, only 11 is dropped, 11 is denied, and rest are what? Permitted. Did you got it? So 172.16.10.2. See, I'm getting the replies, all right? In fact, I can do telnet as well. Telnet 172.16.10.2. I'm allowed to do so. Admin Cisco @123. I'm allowed to do so. Okay, so I can do anything from PC2, PC3, PC4. Only PC1 is going to not work, right? In fact, I go to PC3 and try to do ping. It is going to ping. Ping 172.16.10.2, which is our web server. You see this on the right side, it is going to ping. Yeah, the first packet will get dropped for ARP resolution. Rest packets will be successfully pinged, right? In fact, I could able to do the telnet as well. Telnet 172.16.10.2. Enough. Look at this. It is successfully there, right? Cisco @123. What is it? Admin and Cisco @123. I'm there. Do you see this? I can able to also access web services on the other computers. So if I say HTTP colon double slash, what is it? Yeah, 172.16.10.3. This is the IP of our HTTP server, right? So if I go, you're going to get the access, right? Also, you can get the access for FTP, right? What was the FTP IPs from PC3? So if I go and say FTP 172.16.10.3, this is our FTP server. I can able to access this. Username was Cisco. It was not admin, sorry, Cisco and Cisco. So only what who is denied? Only PC 11 is one is denied, which is having 11, and rest of them are permitted. Got it, guys? So this is all about standard access list. Now we are going to the extended access list. Okay. So in extended access list, what is the objective? Look at this carefully. So I'm putting down two objectives here. Yeah. Number one, deny 192.168.10.11, which is PC1, and 192.168.10. It is not 10, sorry, it is 100. Here also it is 100, PC1, and 100.12, which is PC2. We have to deny this two computers whenever they are going for what? To destination. To destination. What is the destination? 172.16.10.2. If they are going for 10.2, we have to deny them for telnet. Okay, we have to deny them for telnet. Okay, second objective, we have to deny them for both of them for telnet services or telnet service. Okay, and then again we have to deny them for other service. So my second objective is I want 11 and 12 to whenever they go for the other server, which is my FTP and HTTP server, I have to deny them for HTTP. Got it, guys? And third, I have to allow rest of rest of the PCs for all services. Got it? Is it clear? So I want 11 and 12 when they are going for 10.2, telnet should be denied, and when they go for 10.3, HTTP should be denied. Rest everybody is allowed for all the services. So 11, if you go for SSH, is allowed. 11 and 12. Also 11 and 12, they are going for HTTPS or FTP, they are allowed. Got it, guys? This is how what is the objective. So we have to use which access list? Standard is not going to work there. So we are going to use extended access list here. All right. So what is the range of extended access list? Any access list in a range of 100 to 199 is considered to be extended access list, which is going to filter traffic based on source IP, destination IP, transport protocol, source port, destination port. So when we talk about telnet, what is the port number of telnet? Port number of telnet is 23, and it operate over TCP. Operate over TCP. What is the port number of HTTP? The port number of HTTP is 80, and it operates over TCP as well. Okay, so let's go and configure these objectives. So before I do so, what I will do, I will remove this access list which we have created. So how I'm going to remove? No access list 50. So this is going to remove the access list 50. Also, I will take out that access list from the interface. So I'm going to say no IP access group. Do you see this? This is how we apply, and this is how we take out. No IP access group. I have to write no in front of it, 50 in. So we are, just took out our access list from the router as well as from the interface. Now, what is our objective? We have to deny 11 and 12, which is PC1 and PC2, whenever they go for 10.2 for telnet, And whenever they go for 10.3 for HTTP, that is what we have to do. So let's go and do it. Right? Shall we proceed? Okay, let's proceed. So I'm going to say access list. Now this time no 50. I'm going to use 150 pieces because this is extended access list. And then I'm going to say deny. Okay. What is the protocol? Both of them uses TCP. So I'm going to use TCP. What we have, whom we have to deny? Who is the source? The source is 192.168.100.11. What is the destination? When he want to go for a host, destination 172.16.10.2. Okay, equal, you know, 23, equal 23. So if I say equal to 23, so it is going to, yeah, whenever this source will go for this destination for 23 service, it is going to get denied. Okay, all right. And also we want it to deny when it go for 3, you know, it should not able to access HTTP. So port number of HTTP is 80. Similarly, we want to deny 12, right? 12 when it goes to 100.2 for telnet, and also 12 when it goes to 100.3 we have to deny it for HTTP, and then we have to permit all of them. So access list 150 permit. I'm going to say TCP any source, any address, any port number, rest of them. Okay, excluding them, everybody is allowed. Okay, and then also I'm going to say access list. Like for ping, we use ICMP protocol, right? So we are going to say permit ICMP, ICMP, any. So ping is also going to work here. So this is step number one. What is step number one? To create an access list, right? So that's why I'm going over here. So step number one is what? Hello guys, what is step number one? Create an access list, right? So this is how we are going to create an access list. Got it? All these commands as per the objective we have created. What is step number two? Step number two is to apply an ACL. So again, we are going to apply that ACL on the same interface. Got it? Hello guys, we are going to apply the access list on the same interface. So I'm going to say config T. Yeah, let's go there. I'm already there, and I'm going to say interface FA 0/0, and I'm going to say IP access group. Yeah, what was it? 150, and for inbound direction. So this is how I'm going to apply the access list. All right. This is how I'm going to apply the access list. All right. So this is the second step. Okay. Now we are going to test. So let's send a telnet packet from 11. It is going to get dropped. Then we'll send HTTP packet from 11. It is going to get dropped. But if we send a ping packet, it is going to be successful. If we send an SSH packet, it is going to be a successful. HTTPS packet is going to be a successful. Only telnet and HTTP is going to get denied. So let's go to PC1 and let's try it. Okay, shall we try it? So first I'm trying to ping. It is going to ping. Yeah, because ping is allowed. Do you see this? What is not allowed? Telnet is not allowed. So let's try to do telnet 172.16.10.2. No, it is blocked. Yeah, it is denied. It's not able to do it. Did you got it? So if I go and see the show access list, you will see matches. Yeah, for 11, do show IP access list. This is the command to see access list. So you will see 4 matches. Do you see this? 12 matches for telnet. And also I have sent 4 ICMP packets. So it is under the permit. You see this? Again, if I try to do HTTP, it is going to show me the matches and it is going to deny it. So let me go to PC1 and let's try HTTP. So let me go to the web browser. What was our address? It is 172.16.10.3, right? Yeah, and it is going to work. It is not going to work, right? You see this? 10.3 is our HTTP server. So if I go to PC1, it is not going to work. Request timeout. But if I try HTTPS, it is going to work because it is allowed. Did you see that? So only Telnet and HTTP is not allowed. In fact, if I try to do SSH, it is also going to work. 10.2 username admin, only Telnet and username admin. Telnet and HTTP is denied, rest is allowed. This is how we are going to, yeah, work with standard access list. Got it, guys? So this is how the standard access list. Okay. Now, guys, what I'm telling you. Now I'm changing the objective. Now I want to deny 192.168.100.12, which is PC3. Sorry, 100.13. 12 is already denied, right? 100.13, okay, which is PC3. Whenever it go for destination, what is the destination? Whenever it go for destination 172.16.10.2, it should be denied for telnet and SSH both. Okay, now I want to deny 100.3 when it is going for 10.2 for telnet and SSH. So what I'm going to do, I will go to my router and I will add one more one statement, right? So I will say access list 150 is our access list, right? Which we just have created. And I'm going to say deny TCP host. What was the IP of our PC3? It is 100.13. When it is going for destination 172.16.10.2, and this time I'm using range because what is the port number of telnet? 23. And what is the port number of SSH? 22. So they are under the range. Do you see this? I did not use EQ because they are in a range, so I have used range over here. Okay, and I'm going to hit enter. My question is it going to get denied? Think about it. Is it going to get denied? Because now I'm adding a statement. This statement will get a sequence number of 70, right? We have already how many statements? 60 statements, 60 sequences are there. So we are added one more statement, so it's going to get a sequence number of 70, right? But what is this 50 statement? Permit TCP any. And then I'm going to say deny this 10.13. It is not going to get denied. You want to see? Look at this. Do show access list. Okay, do show access list. You will see our statement which I have recently added went down before permit TCP anyway. So when he will go to do, he will check, he will send everybody, he will permit everybody, and when he try to deny, he's not going to deny because he has already permitted everybody on statement sequence number 50. Okay, so let's try. So I'll go to PC3 and try to do telnet. It will it will not get denied. It will it will not get denied. It will work. Okay, it will work. So look at this. Telnet 172.16.10.2. It is not going to get denied. Why? Because what was the previous statement? Hello guys, what was the previous statement? If you look at the sequence, permit admin, it is Cisco at the rate 123, and I'm here. See, it is not getting denied. Yeah, why it is not getting denied? Because it is the statement is after this statement. So if the how the list has been filtered, the list has been filtered in sequence, and here you have already permitted all of them, and then you are going to say deny, so it is not going to get denied. So what is the solution? We should add this statement before permit statement. We should add this sequence statement before permit statement, but that is not possible with standard either extended. Manipulation of sequence number is not possible with standard and extended access list. and hence named access list comes into picture. Got it, guys? Named access list. Okay, what is named access list? It is numbered. We can also give an access list a numbered access list, ACL, or we can also give a name to it, name ACL, like my access list, your access list, our access list, whatever name you want to give. Okay, it could be standard. If this named access list can be, we can configure it as standard. Could be standard access list, or it could be extended access list. All right. Okay. What is the advantage of this named access list? Can manipulate can manipulate the sequence number for entries, for ACs, access control entries, yeah, in an access list, which is not possible with standard standard and extended access list, which is not possible with standard and extended access. Okay, so we are going to use the same objective, and later on we have to add this statement. But this is where we are going to add this statement above this one, where above 50. Okay, which is not possible for us to do with standard and extended. So before I go to the named access list, I will remove this access list. No access list 150. So we don't have that 150 access list in place. And also I'm going to remove it from the interface. No access group 150 in. Okay. Okay, so let's go for a extended access list. So I'm going to say IP access list. For extended, it is not going to start with access list. It is going to start with IP access list. And I'm going to say what type of access list we have to make. Extended, because we have to deny for services. If I specify standard, it is going to completely deny for all services or completely permit for all services. So we have to use a standard access, extended access list, which is going to use the source IP, destination IP, transfer protocol, source port, destination port, etc. Okay, so I'm going to say IP access list extended, and I'm going to give a name my ACL. So if you look at the prompt has been changed. Configuration extended NACL. NACL means name access list. So I'm going to deny. What is the option? We have to deny 11 for telnet and 11 for HTTP, 12 for telnet and 12 for HTTP. So I'm going to say deny TCP host 192.168.100.11 to when it goes to host. What is that host? 172.16.10.2 for telnet. Okay. And when it goes to 3, I have to deny it for HTTP. 8. Similarly, 12, when it goes for 2, we have to deny it for telnet. 23, and when it goes for 3, we have to deny it for HTTP. 8. Okay, and then we will set permit TCP any rest of all our permit ICMP any permit ICMP any. Okay, and then we are going to apply that access. How we are going to do that? Interface FA0/0, and I'm going to say IP access group. What is the name of the access list? My ACL for inbound packets. That's it. So what is going to happen whenever we are going to go to PC number 1, PC number 11 with 1, which is having 11 IP, telnet is not going to work. All right, we are going to deny PC1 for telnet. It is not going to work. See, In fact, PC2 also, if I go to PC2 and try to do HTTP, we are denied for HTTP, right? So if we go over here and try to open HTTP, it is not going to work. 172.16.10.3. Yeah, it is not going to work. It will come up with request timeout. But whereas HTTPS will be successful, right? So only Telnet and HTTP is denied. Rest is allowed. So if we go for HTTPS, it is going to work like charm, right? So this is done. Now, what is our objective? We have to add one more statement, right? We will have to deny 13, PC number 3 to 2 for Telnet and SSH. How we can do so? Yeah, so now if you go to our corporate router, if you say do show access list, you'll come to know that if I deny now, it is not going to work. So I have to put somewhere in the middle, right? Okay, I can put in the top by using a sequence number of 5, or I can use put down in the top in before 50 and 40 by using a sequence number of 41. So do you understand? That's why there's a difference of increment of 10. So if you want to add more deny statement in the middle, so you can use 11, 12, 13, 14, or you can use 1, 2, 3, 4 likewise. So what I'm going to do, again, I'm going to go into my access list. Okay. So what is my access list? How we are going to go into my access list? IP access list extended. And what was the name of my access list? My ACL. I'm going to the access list. And this time I'll just put down a sequence number of 41, and then I will give a statement deny TCP host 192.168.100.13, which is PC3, when it go for 172.16.10.2, and we have to deny it for tel SSH as well as telnet. So both are in range, so that's why I have used range there. So if I said do show access list, it is going to be there. You see this? 41. You got it? Previously, what was it? It was there after permit. Now it is there before permit. So now if we go to PC3, yeah, it is going to get denied. It is going to get denied for telnet as well as SSH. So if I go to the command prompt and try to do telnet, yeah, telnet, it is going to get denied. 10.2, it is going to get denied. Are you getting it? Okay. But if I go for what? FTP, it is going to work. Yeah? Are you getting it? So if I go for FTP, say it is going to get denied. But if I go for FTP 172.16.10.3, it is going to work. Right? Username was Cisco, password is also Cisco. This is how it is going to work. Yeah. That is all about access control list, guys. Do practice, do it multiple times, generate some ideas, okay, add some scenarios to the lab and do it. Implementation and doing is very important. Just looking at the video is not going to help you out. Create the similar topology, practice this topology again, and you are good to go. Okay, thumbs up, go and do it. Take care. Bye.